Welcome to Classes with Atish. In this episode, we'll talk about types of equilibrium and how to find what equilibrium a body is in. Okay. What we mean by equilibrium is the net force acting on a body is equals to zero. Okay. So that is, we have all studied that in Newton's laws of motion. A body is in equilibrium if the net forces working on the body is equal to zero. So the body will continue to be in a state of rest or in a state of uniform motion in a straight line. Okay. So let's look at this from the perspective of potential energy. We know the change in potential energy is equal to negative of work done by a conservative force. Okay. We could also write this as a small change in potential energy is equal to a small work done by a conservative force. Okay. Now, what's the definition of work done? Work done is force times displacement, or dot product of force and displacement. Okay. So we can also write this as F, or let's put it as vector form, F dot ds. Okay. Now, if we represent ds as components in x, y, and z directions, then we can expand this and we can write this is fx dx plus fy dy plus fz dz. Okay. Now, we can further then write fx is nothing but minus du dx. Similarly, fy is minus du dy, and fz is minus du dz. More accurately, we can say is this is the partial derivative of u with respect to x. So more accurate would be to write del u del x. Similarly, this is del u del y. Similarly, this is del u del z. So we are differentiating u with respect to x, treating y and z as constants. Similarly, differentiating u with respect to y, treating x and z as constant. Differentiating u with respect to z, treating y and x as constant. Okay. So our condition of equilibrium is what f net is 0. So if f net is 0, it means fx, fy, and fz all are 0. Okay. So to find out whether a field denoted by potential energy U, a conservative field denoted by potential energy U, whether it is at equilibrium or not, all we need to find out is the condition when fx, fy, and fz are 0, which is what du dx should be 0. Condition of equilibrium should be du dx should be 0, du dy should be 0, and du dz should be 0. Okay. So far so good. Now let's talk about types of equilibrium. There are three types of equilibrium. One is stable equilibrium, second is unstable equilibrium, and third is neutral equilibrium. Okay. So because these are all equilibriums, our condition of equilibrium is f net is equal to 0. So that is satisfied for all the three types of equilibrium. So if f net is equals to 0, let's just consider one dimension for the time being. Let's just consider in the x dimension. So du dx is 0, du dx is 0 for all these three. Now, even if du dx is 0 for different cases, it does not mean it might be the same type of equilibrium. Let's take an example. So when we are talking about u versus x, let's suppose we draw the graph of potential versus x. Okay, let's say we have a plot like this. Straight line goes up, goes down. Okay, now we will examine the equilibrium at different points. We will examine the equilibrium at, let's say, x1. We will examine the equilibrium at x2. We will examine the equilibrium at x3. Okay, what is du dx? Du dx is nothing but the slope of ux curve right? Now, what is the slope at this point? The slope of the tangent at this point is 0. So, slope is 0. What is the slope at this point? Again, if I draw a tangent, the slope is 0. Again, here, if I draw a tangent, the slope is 0. So, all these 3 points are points of equilibrium. Okay? But there is a difference. The difference is, let's just imagine a situation. Let's say we have a hollow sphere, okay? Let's say we somehow balance a small ball on top of the sphere. And we also keep the same ball inside the sphere. And then the third case is when we keep the same ball on a flat ground. Okay? If we disturb this sphere here by a little bit, okay, first of all 3 are in equilibrium because there is no net force acting on each of these cases. Now, if I disturb this ball by a little bit, then eventually it will come back to its stable equilibrium position. So that's the reason this is called stable equilibrium. Okay? If I disturb this ball by a little bit, what will happen? Due to gravity, it will fall. It was in equilibrium, but on disturbing it a little bit, it is no more in equilibrium. So this is called unstable equilibrium. Okay? And what would happen here if I disturb it by a little bit? Yes, that equilibrium will get disrupted, but it will quickly assume another stable equilibrium position. So this is defined as neutral equilibrium. Okay. Now, how do we relate this to the graph? Here, because potential around this point is roughly the same, this corresponds to neutral equilibrium. Here, potential is maximum, U is max. So although this is at equilibrium, a slight change in position will decrease the potential of that body, and every body wants to be in the minimum potential area or wants to acquire minimum potential. So this equilibrium is unstable equilibrium, and here u is minimum, potential is minimum. So even if you disturb it by a little bit, the body gets more potential, and any body wants to come back to its minimum potential region. So this is the case of stable equilibrium. Okay. Now then, if we come back here, so let's write when disturbed by a small amount returns back to its stable equilibrium. Unstable equilibrium was the thing when disturbed by a small amount does not return to its stable equilibrium or does not maintain stable equilibrium or does not maintain, let's just say, equilibrium. And this one, when disturbed by a small amount, maintains its neutral equilibrium. Okay? So mathematically, how we can define these three situations? We can say u is minimum in this case. Unstable equilibrium, u is maximum. When I say u is maximum or u is minimum, I mean locally. Okay? What is locally? The reason we are saying when disturbed by a small amount, in this local area, u is maximum or u is minimum in this local area. That's important, okay? And here u remains same. Again, I will write locally. Okay? Now, what's the condition of u being minimum? The second derivative, d square u dx square, should be greater than 0. So, this is the condition of minima. Here, d square u dx square should be less than 0. This is the condition of maxima. And here, d square u dx square should be 0, equal to 0. Okay? So that is how exactly we find out from a potential field whether at a point x, at a given point x or x1, x2, x3, we can evaluate whether it's a stable equilibrium, unstable equilibrium, or neutral equilibrium. Okay? Okay, now let's look at some examples. Let's say we have a field whose potential is given as 8x square minus 3x plus 2. Okay? Find the positions of equilibrium and type of equilibrium. Okay, so how do we approach this? Now, fx is minus du dx. So we can find out the force. So this will be minus, if I differentiate this with respect to x, it's 16x minus 3, which is equal to minus 16x plus 3. Okay? First thing, before doing anything else, you must realize that this field is associated with a conservative force. Only if it is associated with a conservative force we can use this. If it was not a conservative force, we cannot use this. Why? Because change in potential energy or potential energy is only defined for conservative forces. Okay? So it is not defined if the force itself was a non-conservative force. So just be aware before applying this, because at the end you're not applying a math formula to this problem, you're applying physics to this problem. Okay, so you should understand the background behind this. Okay, regardless, we came to find fx. Now to find positions of equilibrium, then fx should be 0, so all net force should be 0. So from here we will find x as 3 by 16. Okay, now at x equals 3 by 16, so this is a position of equilibrium. Now at x equals to 3 by 16, what is the type of equilibrium? So to find the type of equilibrium, what we will do d square u dx square and find out what is its value, whether it is positive, negative or 0 at that x. So when we do d square u dx square, it's, so du dx was 16x minus 3, d square u dx square will be 16, and it looks like it is a constant. So at x equals 3 by 16, d square u dx square is greater than 0. So which means this is a minima. Okay, so at x equals 3 by 16, it is stable equilibrium. Okay, next question, let's look at this. U is given as 12x minus x cube. Same thing, find position of equilibrium and type of equilibrium. Should you write positions of equilibrium and type of equilibrium. Okay. Condition is fx should be 0. Fx is minus du dx. So minus of 12 minus 3x square should be 0. Or we can write 12 minus 3x square is 0, or x square is 4. So x is equals to plus 2 and minus 2. So these are the two positions of equilibrium. Okay. Now to find the type of equilibrium, we got du dx is 12 minus 3x square. Okay. So to find type of equilibrium, we'll find d square u dx square is minus 6x. Okay. So d square u dx square at x equals to 2 is how much? Is minus 12, and d square u dx square at x equals minus 2 is how much? Is 12. This is less than 0, so this must be maxima. So which means this is unstable equilibrium, and this is greater than 0, so this must be minima. So this means this is stable equilibrium. Okay. Now we have a potential which is given in 2 dimensions. let's say u is equal to 12x minus x cube plus y cube minus 3y. Okay. Now we have to find the position of equilibrium and the type of equilibrium. Okay. So in this case, we have to use the partial differentiation. So what we will do is we'll find out fx is minus del u del x and fy as minus del u del y. Okay. And position of equilibrium is when both fx and fy are 0. Okay. So what is minus del u del x? So we differentiate this with respect to x, treating y as a constant. So this will be minus of 12 minus 3x square, or we can write 3x square minus 12. And this one will be minus of 3y square minus 3, or we can write 3y square plus 3. Sorry, 3y minus 3y square plus 3. Okay. Now let's substitute fx is 0 and fy is 0. So from this we get two roots of x. X equals plus 2 and minus 2. 12 divided by 3 is 4. Square root of 4 is plus minus 2. And from here we get y equals plus 1 and minus 1. Okay. Now then, we got two sets of x and y. So we have to look at all possible combinations. So when x equals to 2 and y equals 1, when x equals to 2, y equals minus 1, when x equals to minus 2, y equals 1, and when x equals minus 2 and y equals minus 1. So these are the four possible places of points of equilibrium. Okay, so point A, B, C, and D. We can say at A, B, C, and D, F net is 0. Therefore, these are the four positions of equilibrium. Now, to find the type of equilibrium, what we'll do del square u del x square. So this is del u del x. So del square u del x square, this is 0 minus 6, and del square u del y square is, sorry, this is minus 6x, and this is 6y. 6y. Okay. Now let's substitute each point here. Okay. So let's say del square u del x square and del square u del y square at point A, point B, point C, and point D. Okay, now let me write down the points as well. 2 comma 1, 2 comma minus 1, this is minus 2 comma 1, and this is minus 2 comma minus 1. Okay. Okay, let's see what's the value here. So we substitute 2, so this is minus 12, and we substitute 1 here, this is 6. We substitute 2, this is again minus 12, and minus 1 here, this is minus 6. So at minus 2 it's plus 12, this is also plus 12. At 1 it is 6, at minus 1 it is minus 6. Now what do we do? So when del square u del x square is negative, it means it's a maxima, but del square u del y square is positive, it means it's a minima. So how do we interpret this? The interpretation here is at 2 comma 1, this is a point of equilibrium, but it is unstable equilibrium about x, but stable equilibrium about y. Okay, it means if I move the body in the x direction, it is unstable. It will not return back in the same position. But if I move the body in the y direction, it will return back to the same position. Okay, so this one, so both are maxima here. So this is unstable equilibrium about both x and y. Okay, this is both are positive, so stable equilibrium about x and y. And this one is positive, so this is minima, this is maxima. So stable equilibrium about x and unstable equilibrium about y. So that is how we interpret this result. So this was a quick tutorial on types of equilibrium. Hope you followed through and hope this was useful. If you do like the content, feel free to subscribe and like the video, and I will see you in the next episode. Cheers.